So let's see some. So actually, there is many things wrong with this code. It would work, but it would generally blow up in production. And let's see why. So the problem, like if you are Spotify, you have some tracks that is much more popular than other tracks. So if you try to shuffle it by the same key, you'll get a very tremendous amount of the same track on the single machine, and it will just blow up. That's why just general, even if you do group by key, it's completely terrible. But what we did here, we also did a join. So internally join basically does shuffle as well. So in our case, join will blow up. And there are several strategies what to do. And if you want to ship stuff in production, you need to know about it and be very careful. So the first thing we have, it's called hotkey fan out. So basically what it would do, it would introduce one more intermediate step where it would apply a reduce operation. But instead of having it on one machine, it would have it on an n machines. So here, instead of having a big pile of data into one machine, it would have a separate step where we'll split it into 100 machines, and then we'll reduce it on each machine separately. So this works pretty well, but you need to provide a function that knows about which keys are hot. So it can be hard-coded list of tracks that have problems or whatever. There are actually better techniques to do it. Yeah, it's usually also if you have usually when people have such problems when you have a key of option. So you have an option of int, and then you basically every none value would go to the same machine and will blow up. So usually what you do, you say, okay, if value is none, don't use one machine, use 100 machines. So this is very useful if you get any problems. And usually there are two kinds of behavior you can observe. Things can just crash without the memory, or it can be very, very slow because a single machine would be a bottleneck. But this helps. And yeah, it's better. So in Spark, you wouldn't find such thing. You have to do it manually. But in our Scio, we have it because we have. It's not often. It's not rare when we have such problems. It's pretty often. Second is hash join. So actually, in this case, it depends how much metadata we have. Like Spotify have 30 million of tracks. So the idea is instead of doing shuffle, you can just distribute metadata to each executor and put it in memory. So it works much faster if you have 1,000, 1 million elements. It wouldn't blow up things because you don't have to shuffle.
This is roughly equivalent to broadcasting an app in Spark.
Yeah. So if you use Spark, it's called broadcast in Spark. And so internally, this does kind of broadcast. In Beam, it's called side inputs. Yeah, but this is very, very powerful technique to optimize your code. So it's not a rare case when you have 1,000 elements with some kind of metadata and you just want to join. So use this. Highly recommend. Skewed join. It's something when you want to join. But you know that there is some tracks that have lots of records and you need to deal with it. But at the same time, you cannot use hash join because it's too much. So it's kind of smart. It uses kind of combination of hash join and just join. So there is approximate data structure called count min sketch that can find hotkeys for you. It's kind of accurate, 95% accurate, but usually it's kind of fine. So you get top 100 keys. You do hash join with this case, and then you just do regular join, and so things don't blow up. So yeah, it's possible to do it in Spark as well, but it's not done in Spark by default. But there is a very high demand in Spotify for such joins. That's why we just added it to our library.
So you don't have to explicitly say that you want to use this count min sketch, right?
No, it uses internally.
Well, if it uses internally, don't you include that overhead? Let's say your data is balanced. You don't want to.
Yeah.
You know there's no hotkeys.
Okay, then you don't use skewed join. You just use a regular join.
Okay, you still, as a user, explicitly have to
Yes.
I guess, in Spark or here, nobody's doing it automatically, and I don't think they're doing it automatically for a good reason.
Yeah, but actually Spark, so if you Spark data frames, it can do hash joins automatically because it can estimate the size. But yeah, Spark is not aware of concept of skewed join anyhow. Yeah, so it's kind of, there's no free stuff, so this kind of comes with cost. So just don't blindly use it, but if you know that you have problems here, use it. There's also other kind of join that don't have a slide. It's called sparse join. It's like when you have two very big collections, but you know that intersection that has the same key is very small. It uses Boom filters inside, basically to filter out things that don't have a pair. It's super efficient as well. So you can find it in source code and API docs. Yeah, and if you have some special use case, it's not rare when you have to come with your own kind of join backed by some approximate data structures. Yeah, because the only way you get problems is during shuffle, usually. That's when you start noticing that it's not a pure functional world, it's big data that has its own problems. So, questions? Yeah, so let's talk about testing. During my experience working with big data, I worked in different companies, and I always found that there is a problem with writing tests. Usually test suite is very, there is no tests, or there is a test suite that is very hard to maintain. It's very hard to test. But actually, if we approach in a functional way, there are different techniques. There is some fancy stuff like property-based testing and so on that we're going to take a look. So you can just open this code. We're not going to modify or compile anything. I will just show you some ways to test. I will start with more big kinds of tests and go to more cheap ones. So you can write end-to-end tests where you basically execute local worker and you mock out your input and you pass records and you mock out Avro and you pass command line arguments and you run it. Don't do this unless you really got used to it. It's very actually hard to maintain such tests because there are no type safety at all. So it can be it's like generic record here. Even if it wasn't generic, there is no type checks because it's just an arbitrary input. There is no connection. So if you check what tests are in this project that are mostly transform tests, where you take this function that returns as collection and just run it. And there are some methods. So this is kind of okay. So what we're doing here, we say, okay, put this stuff in memory, make it as collection, and then run this and check that output is this. This is it's like super efficient. So you can run like thousands of such tests in a second. Yeah. Usually the problem is that it's really hard to test something, especially if you have a join. Because if you want to test, if you do like a web join, there are two cases, when there is record and there is no pair. So basically, the more inputs you have, the more kind of complexity of your function becomes. That's why usually most of the code actually are unit tests. So you just have functions that parse something and you test them. But then you can assume, okay, if I call a map on S collection, it would just it's just a map, right? We know there are some. It's not really a functor, but it's kind of a sort of a functor. So we would know that this map would get applied by our framework, and it would work. So usually, at least at Spotify, in my team, probably our 80% of code coverage comes from unit tests. And then there is free stuff you can do. So who is familiar with the concept of semigroup? Okay, so basically you just define a plus operation. So if you use algebra BERT, if you use cats, if you use Scala Z, they have something like called monoids or semigroups. And basically, the whole MapReduce, the whole big data is about semigroups. So if you know what is a semigroup, you can do whatever you want. So you just need to understand the concept of semigroup, and you know it because you already did plus. So if you know how to sum plus numbers, you can generalize this concept to a semigroup. So basically, a semigroup is a structure that has a plus operation, and this operation is associative. Usually in big data, you also kind of assume that it's commutative if you want to make results reproducible. But usually people don't care about it. I mean, it also depends how you define equality. So, like for instance, if you take a maximum, and if your max operation is not commutative, you would get random element as a max. Sometimes people don't care, saying, okay, this is correct answer. Sometimes people want to make it deterministic. Yeah, I highly recommend to make it deterministic, because then it will be much easier to debug it. So semigroups, if you want to test semigroup, you can, there are libraries that would, you can ask it, please test this semigroup, and it would use these mathematical laws to test it automatically. So let's see. Yeah, see, it would check associativity, this combine operation, combine with 1, combine with 2. It would also check that it's serializable. It's important. Yeah, and in order to implement this test, you just need to define how you want to generate. And all these libraries for property-based testing allow you to do it in a very simple way. So if you're interested in this concept, check, there are a bunch of talks online about this. I'm not going to spend much time. But this is very powerful technique to test everything, because you don't have to write any code, it just works. Yeah, it's super. I highly recommend this. The second things that we actually get free tests for is types. So type, by definition, you check bunch of cases that you have all fields, that you don't have null pointers exceptions, and so on. So have better types, then you would have more correct code. And you're not going to screw up. It's very important in big data world, because if you have a bug, usually you don't notice it because it's very small, and you cannot check your output by hand. So try to write code as more functional as possible, and it would pay off. Also write tests, write property-based tests. We have a kind of test in Spotify you can get for free. It's called doesn't crash test, when you just give it a pipeline and it tries to generate a random input and sees that it doesn't crash. Very super useful. You know, in Scala there is many ways how you can shoot yourself, like option.get, list.head, or list.max, and so on, that throws exceptions. Usually when you have such test, it would just crash your pipeline very soon. Use it, highly recommend. So in general, probably most of code coverage we get from doesn't crash tests, and from property-based tests, and from unit tests. Sometimes some things, like if you want to test that something gets joined, whatever, you write some transform tests, but usually they are much harder to implement and maintain. So we try to keep kind of only happy path tests, not if you want to test some corner case, we usually do it in unit tests or property-based tests. Yeah, so that's very important, because please test your code and have a good types. So now we are going to the next unit. It would be about the cool stuff about streaming. So finally, streaming is something that is much, I'd say, done differently than in Spark if used. Actually, it has unified model to do batch in streaming, Apache Beam. So we can just use our code almost that we have written for batch in streaming mode. And now I'll talk about how it works. So when we are doing streaming, and if you are like Spotify or some like mobile gaming company, whatever, it's very important to understand that there is difference between event time and processing time. So if I played music during my cross-Atlantic flight, event time would be 1, but then processing time would be much, much later because I didn't have any internet on my plane. Or if you go to elevator, like you don't send any messages from your mobile phone, it gets delayed. Or if your message delivery system gets crashed or like needs to be restarted, or you get network latency, or you have a network split between data centers, it always impacts your difference between event time and processing time. So ideally, there is this line, and we should have everything on this line. But in real world, like event number 3, it was created at 12:06, but we got it 1 minute later. And there are some corner cases like event number 9, it was much, much more delayed by 7 minutes. So that's how real world works, unfortunately, and we have to deal with it, especially when we are doing streaming. But luckily, Beam has tools, because Beam was built in Google that has lots of such problems. So to fix this, you have to answer 4 questions. What are you computing? Meaning, are we summing? Are we computing maximum value, average, whatever? Where in event time? So do you want kind of a sliding window? Do you want hourly windows? Do you want one big batch? And when in processing time, meaning there is, of course, there is a certain trade-off between how much you wait for late data and what to do when you figured out that, oh, we got 1,000 more events that were delayed due to network split. So we're going to touch these topics, each of them. So what is being computed? We did it before. We just write some code here with some content hours. What happens? We get one big batch and we process it during, like we start our cluster, we execute code, and sometimes, after some time it finishes and we process everything in one batch. And what we want to do, we want to sum these numbers and we get 51 in the end. So that's what we have been doing before. And yeah, processing time is obviously after we got the last event and can be some. So we get one result sometime later. So there is a way in Beam actually to do buckets by time. You have to say, I want a fixed window, and you want specify how long is each window. And then it can do it for you. You can build these buckets. So what happens here, we start our process and we execute basically 4 parallel streams. And this stream will finish, they will all finish together after some time. So it's kind of a batch, but 4 times, like 4 dependent batch processes. It can be also dependent, and you see like first batch is 14 because there is a sum of these numbers. In this column, the second is some other sum, and so on. Does it make sense? Okay.
Because, like up there, you just put out play tracks.
Okay.
Like anything like this, the link you actually tell it where.
Yeah, there is a separate method that you have to call to say this is event time, or your underlying storage can say is this event time or this event. Yeah, we're going to touch this, but yeah, just miss this on this slide. So yeah, you have to configure which field to use for timestamp, or you can ask underlying data source to give you event times and processing times as well. So actually there are different ways how you can do this. Fixed windows probably are not really exciting, but there are sliding windows and there are sessions. Sessions are very cool, so you can have some timeout, like 15 minutes. So if you don't get any events from user like in 15 minutes, we say the session has ended. And then we do some machine learning on this session, like to build some recommendations or to serve better ads. You can actually have a separate windows per different key. So like key can be user ID, and then it would work. So it's super nice. But the main reason why we are talking about it, because we need some sort of a window if you want to do streaming, because stream is unbounded series of data. So you don't know where to stop. But what we can do, we can say, okay, each 10 minutes we are going to produce statistics for the past hour. So it's kind of a sliding window, for instance. Questions? Okay. So the next question we want to answer is when in processing time. And there is a certain delay between the get events and they are processed on the client. And there is a concept of trigger that controls basically when we want to get our results. In case of batch, we just get results when we process data. But if you want to do streaming, you have to define when we want to say, okay, after this point there are no more events, or after this point we just emit a result. And to do this in streaming, there is a concept of watermark. It is kind of a hint from underlying system how much delay we have. And often it's an art to have a good watermark, but it's not possible in real world unless you have absolute information about all your devices. So there is usually a big bit of trade-off between kind of choosing the right watermark and having a good latency. And luckily in Beam you can configure it in many different ways. So in this case, what we want to do, we want to define a trigger, and we want to say that we're going to emit results just after the watermark. So what happens, we have a green line with our heuristic with watermark, and this line moves somehow and it shapes our events. So after we cross our green line, we just emit a result. So we can do streaming this way. And we have a fixed window by 2 minutes. So it works pretty well. Yeah, we have some sort of heuristic. So you see we have just missed one event here. It's kind of a problem because it was kind of an outlier. So something very unexpected happened. Probably person was in an elevator, or he got some message delivery problems between Asia and our data center. But in general, yeah, see, we got a result. That's kind of nice.
What kind of options do you have for dealing with those things that come in after the allowed wait restoration?
Yeah, so we're going to talk about it right now. But this is a very legit question. So what we can do, for instance, we can do speculative execution. So we can reduce our latency. So here there's a bunch of code and we're going to go through it. So what we can do, we can say, please compute result each minute for each kind of a box. So you see for the first box we computed after 1 minute we get 5. Then for the second box we computed 2 times before watermark each minute. The same for the third box and so on. So in Beam you have to write after processing time, after we got the first element, each minute we emit a result. So we kind of speculate on results, but then we get a very nice latency. Or finally, when we are after watermark, we say that if we got a late event, we also emit a result. But there is a valid point, like what we're going to do each time. And there are basically 2 modes. We can accumulate, or we can, it's called discard. This might be a bit counterintuitive, but basically here we accumulate, so we sum 7, 14, and 22. If we discard, we'll get 7, 3, 7, 7, 8. So it depends. If you want to sum, you would sum 7, 3, 4, 8. Or if you want to discard, it would be kind of a separate. So at first it will be 7, then it would be 3 plus 4, a separate result, then it would be 8. In this window, if we discard, it will be 5, and then we would get 9. But on this picture, we just accumulate. So it depends what you're doing, what kind of behavior you want to have. And basically there are 2 modes. And you see we specified something called allowed lateness. meaning that after 1 day, we assume that we get everything. So if you ever got event that's wait more than 1 day, we just discard it. So that's how it works. There is a bunch of different kind of options you can configure, pretty very flexible. Does it make sense?
So if you get something that's beyond that 1 day, can you somehow see that it like counts how often you're actually discarding data in that?
No, as I know. Yeah, I don't know how to do this. So, yeah. But usually, yeah, you just specify some very, very big number that you are very happy with it, and then you say, okay, our message delivery system is good enough not to have 1 day latency. Yeah, so basically, using these handles, you can go from classic batch, as we did before, to batch with windows, or to streaming. Or you can handle wait data, and you can decide what you want to do with this. It's super flexible, very nice, works. So it's not often. Sometimes we have the same code running in streaming mode in batch, because in batch it gets our like kind of, yeah, we have to wait probably for 1 day to finish the whole window, but then we get very, very accurate results. But in streaming mode, we can run the same code in streaming mode, and then we get kind of very low latency results that are probably not 100% accurate, but sometimes for many things you don't need accurate results. If you're not doing financial reporting, if you're doing machine learning, you are fine with 99.9 accurate results, like 99% accurate results. So I have some code for you. Probably by this time, SBT has done all the dependencies. So we're not going to read Avro files from disk. Instead, we're going to go to some test that emulates different kinds of problems you can get with your network. So what we have here, we want to compute content hours in window mode. So there was a question how to choose a timestamp. So you can choose timestamp by this method, timestamp by. Or often your data source gives this. Then you can say, I want fixed windows of 10 minutes, and I want these options. And you can find different kinds of options on the other side of cheat sheet. So we want to get MS plate, and we want to sum them. And we ask Beam for timestamp, and we add it to output. So that's how we get content hours in fixed windows. So if you want, you can do these sliding windows or some other type of things. You can configure lateness, the way we trigger things, how we accumulate, and that actually what we are going to do right now. So if you run tests, run them with test unit 3. The first 2 tests will pass, but then this one will fail because we haven't set up the way how we handle await data. So I want you to do this. So yeah, just open tests. So what we have here, what happened? There was an event. Then 1 hour has passed, and we got 2 other wait events. So by default, it would be discarded. And what I want you to do is to configure the way how we handle wait events. So this test will pass. And you can find almost an answer in this cheat sheet. And if you have any questions, just raise your hand. Or if you want to ask something not about exercises, but about something related to this talk. So, has anybody finished?
Yeah.
So there are many ways to solve this problem because kind of tests are very forgiving. Yeah, so for instance, what I did is there is a trigger that first triggers after the end of the window, and then when we got a new element, it waits for 10 minutes just in case we got more, and then outputs them at once. So you can configure it in a pretty flexible way. If you want, you can imagine some goal and try to implement it and see how it works, because basically you get the whole kind of structure to test any kind of network problems you can get. Yeah, but almost to fix this test, it would be enough. Probably just even to do like this. Let's see. No. Like this. So, but if you want to do like kind of in real world, if you want to do like good batching, if you don't want to overwrite your result after each wait event, usually you have some window where you wait for more wait events. And yes, this is also allow waitness that matters. So if you try to tweak it, like if you place it to 0, if tests pass right now, they should fail.
So will that only make one element? Because that reach in order will go, once it gets into that window, it triggers off, and then you pass this element, and that late element that comes in will trigger it again.
Yes.
What happens when another late element comes in?
So
This
usually you write repeatedly forever, and or the other way, for instance, we can do. Don't quite remember how to do it. Let me see. Yeah, you can, like if you got an element, you wait for like 5 more minutes for other elements. It's one of the options.
and then if one late element comes out 5 minutes after it just drops. Or does it?
So it would kind of trigger a new window once you get trigger a new pane. It's called once you get a new element. Wait 5 minutes, collect everything, and output. There is also a way. Let me see. There is also a way how we can say, like, I want to emit results if I got at least 1008 events. So in general, if you want to check out about more options, you can just check Beam documentation, because there is nothing we have invented in Spotify. Just this is plain Beam API. Basically, we made some things much nicer to use from Scala, because also Apache Beam is very, very low level. So it's more kind of essential set of primitives to do data processing, but we built kind of a syntax sugar on top of it with all these fancy maps and flat maps and so on. So, is there any questions?
What runner do you guys use when you're not in Google Cloud?
We don't run our pipelines anywhere except Google Cloud, I will say.
You had the nice picture of your rack, so I figured.
Yeah, but technically you can use a Spark runner. You can use Flink. So if you okay, let's see. There is a metrics on Beam website. Like,
It seemed like the Flink runner was the most cool feature within the data programs.
yeah. So it also depends if you use batch or streaming. Batch is much more kind of developed in runners, but streaming, yeah, I haven't tried but I would say I'm pretty sure that Dataflow works very good with streaming, but I never tried anything else. I mean, I'm pretty sure Flink also works, but Spark, I don't know.
Yeah, so stateful parsing with Spark is the watermark Spark.
Stateful is a new feature that we don't have in our kind of wrapper yet. So there is a Beam 2.0 that was released like a week ago or 2 weeks ago. We haven't migrated our code yet, but it has a stateful stream processing. But also, kind of, you can always access plain Beam APIs from Scio. So some people have some very special requests when they want to use some library for Beam, or if they want to tune something that we don't really expose. You can always access plain old APIs if you want, or you can wrap them. So we have, for instance, we have some nice features. So we add cryo encoders. So actually, just a simple experiment. So by default, if you use Java serialization or if you use cryo, when we switched to cryo, to the steps that just shuffled a case class with like 10 string fields. So you can't really optimize encoding, but when we switched to cryo, it was the whole pipeline was 20% faster. Especially cryo encoders super efficient when you have enumerations like ADT encoded as ADT, because then I can just put a number like a byte. Also, yeah, if you use like some custom Java library for time, like we have a cryo coders for Java time, but I'm not sure that in Scio it registers by default Java 8 time encoders. So if you want to optimize cost, it's nice idea to register custom encoders. Probably one more thing, you can check a cheat sheet. It has something called like these accumulators. Let me show it how to use it. So we can go back to our example where we discarded checks. Usually, when you do such things, you expose metrics from pipeline, saying how much things you discarded, or what is profile of data. So there will be a new API very soon that is called Metrics API, that is Beam 2.0. But right now you have to write something like with accumulator, and you define accumulator, like count like we can count in, count. Right now you have to explicitly, so it's very, if you use Spark, and Spark is different, but you have to explicitly say I want to use these accumulators. But it has a benefit, so if you use Spark, Spark doesn't have a transactional counters. So if a stage in Spark gets retried, and if you increment counter in not in action but in map, you would see, sometimes you would see duplicate increments. But in Scio it's done correctly. If you don't use Spark backend, but if you use Google Dataflow backend. So yeah, so basically if you write with accumulator, it returns something called S collection with accumulator that passes some context to each method. That's not very nice to program against, but you can do. The other way, there is a package you can import. It's called Scio accumulators. They can do count. So we can do like this. So we can count before and after, and then what we can do in the end, we can do pause, wait for, and then can do you can get a total value, and then like one of the ways you can just throw exceptions, like to crash everything. You can create page duty alerts, you can do whatever. In Spotify we have internal service for these things where we collect profiles from data and apply some anomaly detection and some other methods on this. So like each team gets this stuff for free. Yeah, but you can always export counters and apply anything. I know some people do like some Python anomaly detection code. Like there are libraries by Netflix, Twitter, very useful. So if you suddenly detect that you have a bump in count of messages, something, or if you have a dip in count of messages, probably you have a problem. Yeah, it's very cheap way, but actually, yeah, sometimes you can save yourself from lots of trouble.
Do you guys feed your Dataflow pipelines with Google Cloud?
Yes. So we don't have much real time. So mostly, probably like 95% of pipelines are batch, but we have like 5% of people doing some machine learning online and so on, and they use PubSub mainly, because we had Kafka before PubSub, and we are happy to throw it away. Now we just use PubSub for everything, because it's much more reliable. There is a blog post about this migration. You can read it in Spotify blog. There is a blog post. Webs. Like reliable export of Google PubSub, and in our tech blog. But yeah, basically we had lots of operational trouble with Kafka, because probably we also not used the latest Kafka, and we also had some, because probably the main problem because we had many data centers. So cross data center replication didn't really work well for us. But Google has much more stable network and much better event delivery, so right now it works much better. Yeah.
Do you do Luigi or do you orchestrate everything in Scala?
So we have a scheduler called Styx. It's open source, but some people still run Luigi inside this scheduler because there is some code that was written and people don't want to rewrite it. But we don't have replacement for Luigi in Scala yet. Yeah, but sometimes some things break because of this Python. But there is no kind of a very as good solution as Luigi yet in Scala.
So how is it implemented as some kind of custom implementation for each backend? So for Spark, I know there's native accumulator in Spark.
Yeah. I haven't seen how backends are implemented, but yeah, there should be a separate implementation for everything because Spark doesn't have consistent counters, atomic counters, but Beam has, but Dataflow has, for instance. So yeah, you can learn more. There are a GitHub repo with code of this library, and you can read Beam documentation as well. And also there are two papers. One is Google Dataflow paper, and second is Millville paper by Google. Very cool papers. Highly recommend. Dataflow paper and Millville. So it's streaming.
Actually has a lot of papers on like watermarking as well.
Mm-hmm. Yeah, in general, watermarking problem is very interesting. Oh, thank you for coming.
Thank you.